Thank you for joining me today for the Equals Math Instruction and Support at Levels 1 and 2 webinar for students with moderate to significant disabilities. I will be providing you with information about the lessons, focusing on students who need additional adaptations, specifically students who require concrete objects to understand math and support for language and motor skills. Essentially, I'm talking about support for students that are necessary in order for them to be active learners of math. As you know, expectations are adjusted for students at levels 1 and 2, but at the same time, there is an increase in expectations from what has been expected in the past. So let's think more about instruction before we dive into access to that instruction. You will see examples of all of this in today's training. Learning happens when students have models and examples to follow. Models are often missing from math class generally, but surprisingly absent from special education classrooms as well. I tend to think this comes from the amount of data teachers are asked to collect. In some classrooms I visited, I was hard-pressed to find instruction present. Instead, I heard the students grilled with question after question. When this happened, the students looked panicked and clueless as to what their teacher wanted them to do. They need to see what it looks like and what you are asking of them. Learning happens when students use language to understand, talk, and think. So obviously, they need support to do this. This means they may need access to the device or language system that has been chosen for them, but also a way to talk about what is happening in front of them in math class. You will see how to use lesson materials to do this. Learning happens when students connect new information to what is known, made possible by the design of Equals lessons and the order of the lessons, so it is very important to stick to that order. Learning happens when students engage in activities that active learners do in context, over time, to increase language and understanding, doing things and talking about it. We must remember that students learn over time when that knowledge is connected to what they know. Your students are active learners who observe, think, act, and talk about it. Let's think about it this way. Before you teach a lesson, ask yourself these two questions. What does learning look like for my student in this lesson? How can I make this happen? When you think about teaching in this way, you are creating opportunities for the student to reach his or her potential. The basic steps to supporting students is to identify goals and expectations, then to provide access. Basically, you'll begin here. Place your student based on math knowledge, read the lesson objectives included in the chapter, review students' present lesson, and consider amount of lessons that will be taught in 1 year. Identify a specific skill to be targeted, and consider additional outcomes outside of lesson objectives. Additional outcomes are other ways students show progress. Many times, these are sidestepped in favor of an answer on a test or collected data. Yet these are as legitimate as any measure of math knowledge because they are steps closer to math knowledge. Students show progress when they establish supports for more independence in completing actions and using language, name objects, math tools, and actions, gain partial math knowledge, problem-solving process in every lesson, learn cause and effect, imagine, predict, and estimate, increase understanding, vocabulary, action words, which are important for cause and effect, attention to instruction, tolerate touch of math materials and tools, and make choices. Give choices with lesson materials. Allow students to make a choice in a way that works best for them. This may be pointing, touching, eye-gazing, or using the step-by-step communicator. It's important for the student to see what happens after a choice is made. One way to do that is to follow through on a choice, whether it is correct or incorrect. For example, I could show this display, square, rectangular prism block, and the cookies, in the pocket chart display. Place these materials on the table as well, all the squares, blocks, and cookies. I can ask, which would you use to make a tall tower? Student chooses the square, for example. I would take the squares and make a tower. Now we can talk about the tower. Is it tall? Is it the best choice for a tower? What else could we use? This is an excellent example of reasoning using cause and effect, and it teaches the student that trial and error is acceptable, mistakes are okay, and it is fun to try things out to see what happens. While Equals Math has flexibility, it is very important the lesson structure is maintained and math vocabulary is used as is. The flexibility lies in the ability of the teacher to reduce the amount of language, not replace math terms and vocabulary. If you are tempted to replace math vocabulary with your own choice of words, remember instead to use your choice of words to describe the math vocabulary meaning. However, always use the vocabulary words as written. Let's read the vocabulary review as written in the lesson. Show words, read together. Say, look means to see with our eyes. We can learn by looking. Sometimes we learn by looking and touching. Pass mirror around the table so students can look at themselves. Make concrete connections with students. Fasten look pick symbol to plastic mirror. Say the word look. I can look at myself in the mirror. I can look at you. Look at each student. Say, look at me. Wait for each student to look at you. Look for examples in classroom or the poster. Show meaning with materials. Ask, how can you show me what look means? Students take turns showing the meaning by looking at something. This is generally what I would use for students at level 2 or 3. For students at level 1, I would break this down to the essence, repeat, slow it down, and make the interaction as concrete and active as possible. It is important to remember what this is for. Students understanding the word look and engaging in looking when learning. No need to feel bogged down by what you see between the quotation marks. We wrote the lesson that way to make it simpler and easier to get the gist of the lesson component. It is for you, not necessarily for your students. The descriptions and language in each lesson activity give you the basics of what this section is about. Break it down as you need to, but it is always important to keep all math terms and vocabulary as is. You can use simpler words to describe the vocabulary word. Think about the essence of the activity and the reason for doing it. Break it down, go slowly, get students involved, and repeat. Here is an example of how I would present this to my students at level 1 and involve them throughout. Show word. Say look. This word is look. Point to your eyes. Say eyes. These are my eyes. Show each student. Say find your eyes. Help each student find their eyes. Show your eyes again. Say I look with my eyes. Show the word look and identify it. Look. Record look on the step-by-step. Point to card and move step-by-step to each student to repeat look. Show the plastic mirror. Say this is a mirror. I look in the mirror. Look in the mirror. Show each student and direct to look in the mirror. Ask a student or assist to fasten pick symbols or look card on the mirror. Repeat reading the word again, taking turns with the step-by-step. Show an object of interest to the students. Look at it. Say, I look at the cookies. Look. Show each student. Say, look. When the student looks, say, you looked at the cookies. Early lessons are designed for students who need to begin with pre-readiness concepts, the foundation of equals. Take care in placing your students. You may want to look at the Attending and Exploring screening tool if you have not yet used the assessment. One way to support students with significant disabilities is to utilize Level 1 differentiation that is embedded in lessons, worksheets, and lesson tests. Regarding worksheets, on the left is the skill worksheet included to provide a semi-concrete paper-pencil view of the lesson objective. Use concrete materials with the worksheets as needed for students at Level 1. Then show how to place objects to record, then show the student where and how to mark the answer on the page. You may have to cut or fold the paper to make it accessible for the student to circle or stamp the answer. On the right, you see a supported place for the student to record the solution to the problem the student solved individually. Rather than having to write out words, the student needs to circle or stamp the answer, simplifying the task. The worksheet is a very small portion of equals. The value is in the experience. For a learner at Level 1, it is an opportunity to experience a paper-pencil view supported by a concrete view. As already stated, the problem-solving worksheet does provide a place for students to record their solution, which is a part of math. For individual motor, language, cognitive, and vision support, look to the Action Dictionary. Here is the Look page from the Action Dictionary. You'll notice these were designed to assist students with the action of looking by providing a way for students to ask to see something, and some tools such as a slant board, flashlight run by a switch, and a focus window. It is important to remember that especially for Level 1 learners, the examples in the Action Dictionary might not work exactly as written for a particular student. This is when you get creative and look at each example and imagine how to tweak it for the individual student, then try it out. The same is true for materials called out in the lesson. If a particular tool or counter does not work for your student, try something from your classroom that you feel works better. Maybe the counters need to be larger or easier to hold. As long as it works for the math in the lesson, you can make that adjustment. Changing the materials to fit a student's needs is perfectly fine as long as it works with the concept and the lesson objective as they are taught in the lesson. On that topic, now and then I have heard teachers talk about changing or adapting the lesson itself because the lesson objective is too hard. Changing the lesson so it is different than the lesson objective is inappropriate. If the lesson objective is too hard, you would need to consider placing the student in an earlier section or chapter, or focus on building language in the context of the lessons, then determine if the student is making gains in those areas, or reduce the language as I showed you a few slides earlier. I have identified the common student actions that are present in all lessons across equals. This is a good starting point when thinking about what your students can do and how to adapt the actions if needed. Tell, discuss or say. Answer, see or look. Explore, take turns. Record, mark, name, estimate or predict, and choose. For actions not yet adapted, hand under hand is a good, temporary way to help students understand the movement associated with the action until an adaptation is in place. When you are just starting, you may want to focus on the action word cards and this list. Choose 1 or 2 actions to adapt, then start to add more as you move to new lessons. When you are teaching a lesson, there are a number of places that require the use of concrete materials for all students. You will find them in Concrete Connections, linking a concrete version of the vocabulary word to the pick symbol and word. This anchors the meaning of the word in a hands-on manner. Concrete, semi-concrete, and abstract learning sequence is for all learners to better understand the math concept as viewed in these 3 ways. The introduction of the concept on page 1 is strongly connected to concrete objects, and one or both strategies include concrete objects for better understanding. It is very important to remember to model what is expected of your students. Too many times we expect too much from students when we assume students understand all of our verbal directions. Students need to know what we are talking about and what we want them to do. Let's look at specific examples of using concrete materials when problem solving. In this example, the objects in the problem are attached above specific words using a pocket chart and tape. A box is also shown in the problem, but it is too big to tape to the pocket chart, so it is just set on the side. I provided 3 sets of objects as answer choices: ocean animals, cookie shapes, and insects. I can ask my students, what are the facts in the problem? Or, what kind of animal counters did Beth see in the box? Students answer by talking, using a communication device, touching, pointing, or eye-gazing to their answer. Or I could record, that's the one I want, on the step-by-step, and I do the pointing. I am sure to respond to any answer attempt by confirming the choice and framing it in the context of the problem. For example, if I asked the student to choose a fact, and the student chose insects, I would say, you chose insects as a fact. Yes, Beth saw insect counters in the box. That is a fact. If cookies were chosen, I would point to the objects taped to the problem and say, I don't see cookies here. I see ocean animals and insects. Point to the other choices. Say, tell me about a fact in this problem. This is a similar setup. In this problem, I added a card to represent the word pictures in the problem. I provided choices for the problem facts differently here, with 2 choices that are incorrect. You can provide the choices as you see fit, depending on your student's goals and the current knowledge and amount of support needed. For example, if a student is just learning how to make choices, I might make the choices errorless. The choices I have here are slightly more semi-concrete by representing the shapes rather than sandwiches cut in these shapes: rectangle, rhombus, and hexagon. My question might be, which sandwich shapes did Aaliyah order? Remember, students who are early language learners and need language support benefit from using lesson materials to make a comment, answer a question, or make a choice. This is an example from page 1 that includes both teacher and student answers to the questions using the Number Notes poster. It is essential to note that moving forward with lessons in order is in itself a support as students learn important prerequisite skills that support their efforts. We all have learned math over time in increments, not one skill at a time. Think of the learning process as overlapping rather than independent skill silos. We learn by linking new information to what we already know. That is the nature of learning, proven by research. When you are teaching complete lessons in order, you are providing the best practice math instruction that you can. It is important for students to know how the world works when they learn how to solve problems. The tool for learning how the world works is knowing cause and effect. Math is full of examples of cause and effect. It is essentially what math is. I do this, and that happens. It helps us estimate and predict, to choose tools wisely, and know which action to perform. It helps us know if the answer and our approach was effective. When babies are 3 to 6 months of age, they learn that when they cry, they will be comforted, changed, or fed by their parents or caregiver. A baby is starting to understand that behavior results in a response. You might have worked on cause and effect connecting a switch to a toy or music, or rolling a ball back and forth, or even knocking down a tower. All of this is information about how things work in the world. And that knowledge is valuable when learning math because cause and effect is everywhere in math, particularly in problem solving. Here are some examples I pulled from Equals Math. They are in no particular order. We will be looking for examples for students to begin to experience cause and effect and support the problem-solving process. When I sort a pile of objects by color, the set changes from 1 set of mixed shapes and colors to 3 sets of 1 color each. The cause is sorting. The effect is 3 new sets. I begin with a pile of blocks. When I stack them, the pile changes from 4 cubes to 1 rectangular prism. The cause is stacking cubes. The effect is 1 large new shape. When I place 5 triangles in a circle with all points jointed in the center, I make a new shape, a hexagon. The cause is placing the triangles together in this manner. The effect is 1 new hexagon. How can we facilitate practice with cause and effect? How can we introduce basic reasoning to inform a decision? Often the use and effectiveness of manipulatives relies on the teacher's use of them. Models are good, and adapting actions to be performed with them is helpful. But thinking through reasoning is much harder. You might want to try this activity with your students. You can create a collaborative atmosphere that is simple, fun, and inviting. However, do not forget the importance of the structure of a good curriculum which provides a lesson order that promotes connections from prerequisite skills to new skills and new knowledge to what was learned. That means this type of cause and effect activity is much more meaningful when linked to the lesson concept the student is learning. When problem solving together, which is very useful for understanding, the teacher has a huge role in encouraging use of manipulatives appropriately and managing a collaborative atmosphere. Make choices and learn from them to expand thinking and imagination and work together to solve a problem. You can use a simple problem-solving activity to make choices based on reasoning and checking the choice with a cause and effect experience while building a collaborative relationship with small groups. This activity would work well when students are learning how to use 3-dimensional shapes to make a new 3-dimensional shape. For example, students might use rectangular prisms to make a large square, or to make a taller rectangular prism. Which should I use to make a tower, square, blocks, or butterflies. Place piles of all of these on the table. Let's say the students wanted to try the butterfly. Go ahead and try it to see what happens, then talk about it. So you try it with butterflies and they fall down. Did that work? Not that's wrong, but rather, did that work? Could we try another way? Which way made the better tower? Make the differences and usefulness obvious, as simple as you can. For example, when solving a problem when sorting into sets of blue and yellow, make one of the choices red. Try sorting and see what happens. Other ideas? Use the scale as a choice when measuring length. Use 1,000 frames when adding amounts to 10. Throw in oddball choices when you are using a very specific tool or counter. This is basic reasoning. Will this work? Understanding cause and effect is background knowledge for imagining what to do and what might happen when solving a problem. Let's look at what problem solving is all about to see what we can do to teach it and support it. There are basic steps in problem solving. They match the steps on the solve poster. What do I know? Use concrete objects that represent facts and choices. What do I do? Use familiar actions paired with demonstrations of the action and give choices. What do I think will happen? Pair possible effects with concrete objects to aid students with estimating and predicting, and give choices. What do I use to make it happen? Provide familiar tools that can make it happen, and give choices. What happened? Pair different effects with concrete objects to represent problem-solving solutions, and of course, give choices. With appropriate support and what they have learned, students can make choices about facts, actions, strategies, and outcomes in word problems, then solve with manipulatives and talk about what happened. For students who need support in thinking what to do, narrow the possibilities by giving choices. This is the very first lesson in Equals. For that reason, I expect to provide the most support in this lesson so my students will know what I am talking about and what to do. Let's take a look at what Math Dash might look like in Lesson 1A1. Before we begin, remember the action cards are introduced here. The words are show, look, and touch, and there are cards to match, which need to be paired with the action itself as the word occurs in the lesson, or you take time to show them as part of a daily review. Connect action cards to actions as they occur. I can extend what we did in vocabulary review. For example, I placed the concrete connections for look and the step-by-step communicator so vocabulary is supported. We can pass around the book or paint or crayons and practice looking and touching. I can reduce language and use statements rather than questions. For example, instead of how can you look at the paint, I can say look at the paint. Or I can pair the question and answer how can you see your friend? Look at your friend. In the first part of Explore and Connect, students become familiar with people or animal environments. School was chosen for Chapter 1 because the students in Chapter 1 are just starting out, and they are actually in this environment, so they can more easily relate to it and make sense of the idea of an environment that will be used as context for solving problems later in the lesson. Poster cards to the right of the poster help students focus on or see one item at a time with close-up photos from the poster. The cards can be used as choices to assist students in talking about the poster. Actual objects from school that are on the poster, such as pencil cups, markers, pencils, ruler, paint, and lunch tray, plus materials from the kit, cubes, math line, cookies, flying discs, and egg legs constructed into shapes, can also be used to locate pictured items on the poster and/or provide a concrete way to talk about what is there. I can create a display as you see at the bottom right. I can point to a tool on the poster, for example the math line, and ask, which math tool is this? Students can answer by indicating with pointing, eye gaze, or touch. Remember, if a student is unable to do any of those things, record, that's the one I want on the step-by-step, and you do the pointing. The Math Tools portion of Explore and Connect typically features tools students use for understanding the problem-solving strategies in the lesson. As students are taught to attend by looking, touching, and talking about the tools, real tools from the kit are provided. In this example, the teacher begins by showing what to do with the math tools by stacking the blocks. Repeating this with other tools means the teacher will show what you can do with other objects, such as slide tabs on the math line, and touch, examine, and sort the shapes. Then, students explore the tools. Are the students learning to make a tower, or count, or sort in this lesson? No. The objective is student will attend to math instruction. Counting, sorting, and stacking are examples of actions, which are a part of math instruction. They are also great examples of cause and effect. In show and tell, the teacher provides another model of doing and talking about it. So the teacher shows more about the tools, specifically referring to the colors and shapes, and moving the math line tabs, and showing the numerals, perhaps counting. The students are learning that learning math is looking, then doing. Attending includes both looking and doing. Still in show and tell, the teacher moves on to asking and answering questions about what they have been doing and using, and provides a display of math tools and/or action words, show, touch, and look, to use. The teacher asks, "What do I know about math tools?" then shows how to answer and record it. For example, I know I can touch math tools. The teacher asks students, "What do you know about math tools?" One student might choose the word look, or the math line, or both. The teacher interprets the choice and records it. For example, yes, you can look at the math line. Another student chooses blocks. The teacher moves and makes a tower with the blocks, and might place it nearby with the word show to emphasize the action of showing a tower and saying, "Yes, you know we made a tower with blocks. I can show a tower I just made." The next question is, what do I want to know about math tools? The teacher can place more tools on the table, or just use the ones from the lesson. Answer first to model a response. I want to know, can I explore ocean animal counters by touching them? Then ask, what do you want to know about math tools? Or you could ask, what math tools do you want to explore? As students answer, record using the actual items on the table. After introducing the new vocabulary word math, we begin problem solving with the model and think about it. In prepping for this lesson, I am going to set it up in front of the students. I want them to see the blocks under the box and the shapes in the bag. The math line is in plain sight. This is the problem and think about it. George has a mess. He wants to work on math. His tools are missing. Where are George's math tools? That's a bit wordy. I want to reduce the amount of language while maintaining the integrity of the problem. George has math tools. The math tools are covered. Find George's math tools. Read one fact at a time from the problem. You can highlight, circle, or underline each fact summarized. Pair the fact with objects and/or action cards. Write each on the poster. Let's see what this looks like for Level 1 students. I chose to identify the first fact. The math tools are covered. I need to show my students what I mean by that fact. I show the math line and say this is a math tool. I can see it. It is not covered. Peek under the box and in the bag. Say, it looks like these tools are covered. They are covered by the box and the bag. I wrote the fact tools are covered on the poster. I now chose the second fact, which indicates what is needed to solve the problem. I say, this is a fact that tells us what we need to do to solve the problem. Find George's math tools. When I want to know where the tools are, I look for them. Find the math tools means to look for the math tools. I wrote this fact on the poster. The next step in thinking about this problem is to number 2, choose an action. This is the very first thought. What do I do to solve the problem? You and the students can change the action later as they think it through further. Demonstrate the action cards from the lesson. Show the math tools, look for the math tools, and touch the math tools, using the open and covered materials on the table. These actions have already been shown on page 1, so students have seen this before. I show one card at a time and demonstrate in the context of the problem. Will I be giving away the solution? For some students, I might be doing just that. But the concept of a thinking process is very abstract. I need to show the possibilities of what I can do to solve a problem. This is an opportunity to see what problem solving looks like as concrete as possible. Say, I can show one of the math tools. I can show the math line on the table. Fasten show on the poster. Say, I don't see other math tools. I can look for math tools. Show how to peek under the box and in the bag for math tools. Fasten look on the poster. There is a third card here, but I don't have to use it. As a matter of fact, I could use one action card if I wanted to keep things simple. I would be sure to pick the one that would solve the problem at this point, so I would choose look for the math tools. 3. Making a prediction is a reasoning skill. What is the most reasonable outcome? What will be the result of my actions? This can be a difficult concept as it requires some imagining. As a matter of fact, experiencing cause and effect helps students prepare for this step. Let's make it concrete for Level 1 learners. Show the math line. Say, this is a math tool. The facts say there are math tools, not just one tool. Show the box and the bag that have math tools inside. Say, the choices we find just the math line math tool. Point to the box and the bag and say, or, we find more math tools. We saw something under this box, and this bag is a little heavy. I think there are math tools under the box and in the bag. Write the prediction on the solve poster. Step 4. Choose the tools and strategy. It's simpler and more concrete to provide tool choices to represent the strategies. Say, I will choose how to solve this problem. Look under the box and in the bag, or look in another place. Write the tools or strategy on the solve poster. I choose looking under the box and in the bag for the math tools. Step 5. Solution. Uncover the tools and write the solution on the poster. I looked under the box and saw math tools. I looked in the bag and saw math tools. Let's look at this again from a lesson that's a little bit later in the curriculum, Lesson 4A3. The objective here is student will solve join result unknown problems, sums to 10. Let's take a quick look at problem solving in Chapter 4. After warm-up with review vocabulary and a game, students begin to work with the math concept in Math Dash. Here they are placing amounts on a work mat to learn how to place an amount and start, another amount in change, and move them together to add them in result. This particular work mat lays out cause and effect for addition. I move two amounts together, and that makes one larger amount. In Explore and Connect, students explore the theme of the lesson to set up a context to solve a problem. In this lesson, it is working at a pet store, using money cards and cylinders for cans of dog food. In Math Tools, students gain more experience with tools they will use when solving problems: connecting cubes, stacked number line, and math line. Show and tell using the number notes is next. All math tools for this lesson should be on the table for students to use to communicate what they know and want to know, whether it is useful in helping students express verbal thoughts, or students choose the objects themselves to make a comment or answer a question. Often providing 2 to 3 choices assists a student in communicating as the possibilities are narrowed to a reasonable amount. However these are used, communication and attempts to communicate are honored and restated for clarification, then displayed. We have moved past new vocabulary and right to think about it. Let's take a look at the problem and strategies as we fill out the problem-solving poster. You can see the problem supported with objects. Mr. Brandt works at the pet store. A customer gave him 5 $1 bills and 3 $1 bills for a bag of cat food. What is the total amount the customer gave him? Let's begin with identifying the facts. What are the facts in the problem? 5 $1 bills, 3 $1 bills, Mr. Brandt works at a pet store, and we are finding the total amount the customer gave Mr. Brandt. What can I do to solve this problem? What is the action? We will add and count. What is my estimate? What will the total amount look like? I see the choices 10 $1 bills, $1 bill, and 2 cans of dog food. When I add 5 and $3 bills, I know that's more than $1. I can see it is more than $5. I think the total will be about $10. Tools and strategy. I will choose how to solve this problem. use the math line to say first amount and count on tabs. 5, 6, 7, 8 to add, or use WorkMat 35 to count amounts in start and change. Then add the dollar bills and count the total amount in result. I choose Count On using the math line, and here is the solution. I counted on from 5 to add 5 and 3 more dollar bills. $5 plus $3 equals $8. You can see how heavily we relied on the concrete objects to support student understanding and their interest. This was the modeling part of problem solving. The beauty of having the lesson materials out on the table is the ability for the student to relate to what is happening and be able to directly use them to talk about what is happening. That is not only a language support, but a cognitive support as well. Thank you for joining me today learning about support for students with significant disabilities. Be sure to reach out to our team at curriculumenablementinc.com for any questions or comments you may have.